Hi, I'm Ben Kuzinski from 20Q Group, an authorized reseller of business intelligence products from the company Business Insight. In this video, I will demonstrate the standard interface of TIM, the Intelligent Mining Machine. The TIM software suite is a software package used for solving business intelligence problems. In this video, we will focus our attention on only one component of the TIM software suite, the predictive analytics engine named TIM. TIM creates predictive models based on your data. Using these models, you can predict outcomes like sales revenue and conversion rates, but you can also gain customer insights, useful in making your products or services even more desirable to your target market. To use TIM, you need a learning dataset and an apply dataset. A dataset is simply a table containing all of your data. TIM predicts the future by learning the trends and patterns that are inside your data. TIM analyzes the historical data that is stored inside the learning dataset in order to create a predictive model. Then you can apply this model on an apply dataset to obtain predictions. Here is a small example of a learning dataset used for building a model that will predict if a customer will buy your product. This kind of predictive model is called a propensity to buy model. A dataset is a table. Each line in the table is a customer. The columns represent all the information we have about this customer. We know all the past purchases for each customer and some socio-demographic data like profession, marital status, income, and so forth. The more information we get, the better the prediction will be. It's common in the telecommunications or banking world to have over 10,000 columns for each customer. TIM is the only data mining software that allows an unlimited number of columns inside your dataset. One column is special. It's the target. TIM creates models that predict the value of the target column based on the value of the other columns. Once the predictive model is built, you can apply it on an apply dataset, and TIM will fill in the target column with its prediction. Here we will get the probability of purchase for each customer. Here is another example of a learning dataset in the telecommunications industry that is used to build a model that predicts if a customer is about to churn, or in other words, leave the current operator for another one. Using this predictive model, TIM creates a list containing all the customers that are about to churn. This list is very useful because you can propose to the people on the list an incentive that could prevent them from churning. With this technique, you can use TIM to reduce churn in any kind of industry: telecommunications, insurance, banking, utilities, and so on. Churn is a very common phenomenon and appears in nearly all forms of commerce. This makes TIM extremely useful in a large number of situations. As usual, the more information you extract from your database about your customers, the better the prediction will be. Creating a churn model is slightly more difficult than creating other kinds of predictive models because we must pay extra attention to the timeline. Let's assume that we were currently in the month of April. We will go back in time and create our learning dataset as if it were 3 months earlier in January. January is the observation date. The learning dataset is a snapshot of our database as if we were in January. Inside our learning dataset, we have some interesting columns like the percentage of calls outside the network, the number of calls to the support hotline, and so forth. The target column is special. It is true for all the customers who churn between January and April. We will apply our predictive model on an apply dataset to compute the probability of churn for all the telecoms customers. The apply dataset is a snapshot of the most up-to-date version of the customer database. The predictive model will detect all the customers that will leave the telecom company in a window of 3 months. Why is churn so important? Typically, the yearly churn rate for a mobile phone telecom operator is 4%. That means that each year, a mobile phone operator loses 4% of its customers. If we manage to detect these churners and prevent them from leaving, the telecom will gain $9.6 million, assuming subscription fees of $20 a month paid out over the course of a year, that the small mobile phone operator has about 1 million customers, and that the annual churn rate is 4%. Let's say that we are using TIM for our predictions. TIM is able to correctly detect in advance 50% of the churners. The telecom offers to the people who are about to churn free talk time or another incentive, and as a result manages to keep 25% of the potential churners. In this example, the value of the prediction list generated with TIM is $1.2 million. Other data mining software, like SAS, SPSS, or KSEN, is only able to detect in advance a maximum of 30% of churners. The value of their prediction lists is only $720,000. Business Insight works hard on the prediction accuracy of TIM because of the massive value each predictive model has for our clients. In this example, about $500,000 for a single predictive model. The superior accuracy of TIM is demonstrated by its excellent performance at the KDD cups. With TIM, in a few mouse clicks and few minutes, you can generate an extremely accurate prediction list that pinpoints all the customers who are about to churn. TIM also has the unique capability of detecting the reason for each customer to churn. Once you know the drivers for your customers leaving your company, you can correct the situation and further decrease the churn rate. Let's run TIM and build a churn model together. This is TIM's main interface. We already looked at the simple wizard inside another video. We will now go over TIM's advanced mode. First, we have to select a data source. A data source is another word for a dataset. This is where you specify the learning dataset that you will use. The dataset can be a CSV file, a SAS file, an ODBC link, an OLADB link. Using the OLADB or ODBC links, you can access any database directly. You can even enter SQL queries. You can use the Anatella software included in the TIM software suite to create your learning dataset. Anatella is very useful for merging several databases into one large dataset. So, let's browse for our dataset. We will use the cell-to-cell dataset. It's a standard dataset that contains information about all the customers of a mobile phone operator. We can view the dataset here. Each row of the dataset represents a customer. We know the MOU, or minute of usage, of the customer, the monthly recharge value, and much else. And of course, we have our target column. In this example, it's churn. Let's analyze this dataset. We select an output directory that will contain all the results of our analysis. TIM just finished analyzing the dataset and attempted to automatically determine the type of each column. The type information is saved inside a type XML file that appeared inside our working directory. The extension of the file is type XML because it contains the type of all the columns in the dataset. We can click on the Yes button to edit this type XML file, or we can simply double-click on the type XML file to edit it. Now, inside this dataset, we have 69 columns. The first column is the key, the second column is the churn, the fourth column is the mean monthly revenue. You will notice that TIM uses labels instead of the original column names. These labels can be automatically extracted out of the SAS environment, or you can define them manually. This is extremely useful when working with datasets coming from the SAS environment because SAS has very strict limitations on the column names. These limitations are problematic when you want to produce intelligible reports. Thanks to its advanced label system, with TIM you can easily produce clear and intuitive reports without being constrained by SAS's limitations. Each column inside your database has a type. It's either a value column, a nominal column, or a binary column. This binary column is special. It's the target, so we will mark it as the target. And the first column here is the primary key. Let's start analyzing this dataset. The analysis is complete, and TIM generated a new set of files, some standard reports in Word and Excel. After the preliminary analysis is finished, we have three options. We can 1. Look at a crude Olap report, 2. Start a multivariate prediction analysis, or 3. Start a segmentation analysis. Let's look at the Olap report. This Olap report comes in three forms: a Word document, an Excel file, and a simple text document. Let's open the Excel file. What do we see here? Remember that we are analyzing churn for a prepaid mobile phone service. With this type of service, you can buy a recharge each month to add talk time to your account. Recharge values vary from $5 to $100. This green bar here means that inside our population, there are about 14,000 people who buy recharges each month that are worth more than $93. And among these people, 4% of them will churn. This is illustrated by the red line. The red line refers to the axis on the right of the graphic. It is the percentage of churners in each bin. Another example. This green bar here means that inside our population, there are about 2,000 people who buy a recharge each month that's worth less than $10. And among these people, 16% of them churned. You can see a trend here. The more expensive the recharge, the less likely the customer is to churn, which makes sense. We just gained valuable business insight. There's a link between the recharge price and the probability of churn. The next question is this link reliable enough for making business-critical decisions? To answer this difficult question, we must use TIM to create a predictive model. If TIM decides to include the column mean total recurring charge in its predictive model, it means that we can rely on this column to take strategic marketing actions. The columns that are not used by TIM to compute its predictions have no business value. In other words, they have no influence on the churn if you are building a churn model. They have no influence on the sales if you are building a propensity to buy model. All of these Excel graphics are editable. You can change the values in the table here below, and the chart updates automatically. Let's close Excel. Now, let's start a multivariate prediction analysis. To start a multivariate prediction analysis, you can either click on the Start Multivariate Prediction Analysis button, or you can double-click on the config XML file inside the working directory. The config XML contains all of the settings required to create a predictive model. If you need to recreate a predictive model, you can reopen an old config XML file to retrieve all the appropriate settings for creating the right predictive model. See the next video for more information on this subject. Next, we run TIM. TIM is now building a predictive model. TIM combines the variables in all senses and directions to obtain the highest prediction accuracy. Computations are now complete, and we have a new directory inside our working directory that contains all the analysis results. Each time we run TIM, it will create a new directory so that we never overwrite previous results. This is also useful for comparing results. TIM has generated this .model XML file that is our predictive model. We have the charts as PNG files, as well as the word analysis report. Let's open this word report. We see that TIM decided to use only 19 columns out of the 69 original columns available inside the dataset. These are the only 19 columns that have an influence on or a link with the churn. If you want to act on the churn to reduce it, for example, you must act on these 19 columns and not others. When we click on a column, we see the histogram chart that we saw previously. These histograms allow you to see trends and detect patterns. Based on the observed trends, you can determine the right strategic action for your business and act immediately. See the next video on interpreting TIM business reports for more information on this subject. Let's now use our predictive model to see which customers are about to churn. Let's open the Diverse Tool window. First, let's select our new model. We also have to select the Apply dataset. For this, we'll use the same dataset as the Learning dataset. Click Apply, and TIM generates the prediction list. We can open this prediction list inside Microsoft Excel and see that the individual with the primary key 54915 has a 99% chance to be a target. In other words, he has a 99% chance of churning soon. In this example, we applied the predictive model on the Learning dataset, which we used to create the model instead of on a true Apply dataset. Inside the Learning dataset, we always have the target column. If the target column is available when applying the model, then TIM recopies it here. Let's scroll down a little. Our predictive model tells us that the individual with the primary key 208594 has a 77% chance of churning soon, but hasn't done so yet. This is interesting. We must act on this individual to prevent him from churning. Let's now imagine that we have built a propensity to buy model. In this case, it means that the individual with the primary key 208594 has a 77% chance to buy our product, but so far hasn't purchased anything. This slide concludes our short demonstration. TIM. The second-generation data mining software removes all technological risks linked to data mining projects and allows you to exploit the full potential of your databases in minutes. The future of database marketing starts right now with TIM. For more information, please visit business-insight.com or 20q-group.com.